Hello fellow macro enthusiasts, my name is Keith Rice. I am the Technical Director at CADsharp.com, and in this video I want to show you how quickly a simple yet powerful macro can be written once you have a basic understanding of the SolidWorks API. In particular, I want to show you how to write a macro that deletes all of the balloons attached to fasteners in a selected model view on a drawing. So right here I have a drawing that's been auto-ballooned, and balloons 4 and balloons 3 are attached to components that came from the SolidWorks toolbox. So if I select this drawing view and then go to Run on the macro toolbar, which is the same as going to Tools, Macro, and Run, then I can browse for my SWP file, delete fastener balloons, run that, and you can see that those two balloons were deleted. And the idea for this macro actually came from the SolidWorks API forums, and a gentleman wanted to know how he could quickly write a macro to accomplish this. Before we get started, however, let me say that this tutorial may be a little hard to follow if you have no programming experience. If that is the case, I would encourage you to head over to CADsharp.com, sign up for a free membership, and watch some of our videos on programming and SolidWorks API basics. So to get started, I want to create this from scratch, so I'm going to click the New button on the macro toolbar. And you can call this whatever you want. I'll just call it Macro 1. You might call it Delete Fastener Balloons, but make sure that you're saving it as this VBA type macro. VBA stands for Visual Basic for Applications, and the file extension is always .swp. So go ahead and click Save, and once you do, the Visual Basic editor should pop up. And if you're in SolidWorks 2013 like I am, you'll notice that in Windows 7 it will be grouped with the SolidWorks icon. And up at the top here we have the declaration of our iSLDWorks object variable. That's the highest level object in SolidWorks. And then down below that is the main subprocedure. And here we are getting the SolidWorks application. We are setting it, so to speak. And that's the first code we need before we can really do anything with the SolidWorks API. And if you're familiar at all with the SolidWorks API, you know that good programming practice dictates that we should early bind our variables. So that's going to look like this, where we change the type from object to SLDWorks .SLDWorks. And don't forget that you always put SLDWorks first, and then when you hit a dot, this will give you Microsoft's IntelliSense, which gives you a list of all the objects in SolidWorks. And that's when we find SLDWorks, which again, this is the highest level object interface in the SolidWorks API. Now the next thing we're going to do, since we're working within a drawing document, is we're going to declare another variable called SWModel. And this is of object type iModelDoc2. And then down here in my main subprocedure, after I've declared SWModel, I'm going to set SWModel equal to the current active document. And now if we run this, we shouldn't get any errors. Basically, we'll just be getting the current active document, and then we can do something with that. And in our case, the first thing we want to do is get the selected drawing view. So I'm actually just going to write a comment, which always begins with an apostrophe, and say get the selected drawing view. Let's not stop there. Let's actually go ahead and outline how this macro is going to work, so we kind of have a skeleton or kind of an outline to follow as we program. So after we get the selected drawing view, next thing we want to do is traverse the drawing view for all notes. So if you come back here, we're going to select this, we run the macro, it needs to traverse all the notes on the drawing view. Then after that we need to somehow get the entities or the components that the notes are attached to. So if I reload this, in this case whatever 4 is attached to, we need to get this component, and once this opens, you see that it's a toolbox part. We need to somehow be able to determine that this is indeed a toolbox part, and I'll show you how we can do that in a moment. But anyway, we're traversing all the balloons, we're getting the entities that they're attached to, then we're getting the underlying component, and then we're determining if it's a toolbox fastener, and then we're going to delete the node attached to it if indeed it is a toolbox fastener. So let's go back here now and just outline all that real quick. So first, get the selected drawing view. Well, if we want to get any selected object, then we need to use the SWManager object interface. So I'm going to declare a new variable called SWMGR as SLDWorks Selection Manager. And typically what I do is I declare the variable and then I set it. And remember, in Visual Basic for applications, if the variable is an object, then you always have to use the set keyword. So set SWMGR equals SWModel dot selection manager. And if you're wondering, how do I know to type some of these things? Well, basically I would have used the API help when I was learning how to use the selection manager, and if you watch some of our earlier videos from Unit 2, I show you how to use the API help. And now that I have set SWMGR, what am I going to actually get once I get the selected object? Well, I'm going to get a drawing view because that's what I have selected. So let's create a variable for that SWView, and now I'm going to say set SWView equals SWMGR.getSelectedObject6, and the arguments are index and mark. So I'm going to put in an index of 1. That means get the first thing that's selected, and in this case I'm actually assuming that only one object will be selected. And then for mark, I'm just going to put in -1, which ignores marks. And if you're not sure what a mark is, don't worry about it at this point. It's not relevant to this macro. Okay, so now if we want, we can move this comment up above these two lines, where you can delete it if you don't want it. And let's move on. So next we're going to traverse the drawing view for all nodes. How do we do that? Well, we're going to need to use an API call that's called iViewGetAnnotations, and it returns an array. So I'm going to create an array called vAnns as variant, and then down here I'm going to say vAnns equals SWViewGetAnnotations, and that does not have any arguments associated with it. Then after that, we need to traverse all of the elements in this array, and I'm going to use a for loop to do that. And in order to use a for loop, I need a counter of some kind. So I'm going to create this other variable called dim_i as integer, and then I'm going to say for I equals 0 to ubound vAnns, and then close that off with next I. Now for each element in vAnns, I want to set that equal to variable for SolidWorks Annotations. So let's create another variable, and I'll call this SWAN as SLDWorks Annotation, and then I can say set SWAN equals vAnns I. So a few things I want to point out here. First of all, if you aren't familiar with using loops, we do have a free video on that in our first unit. And the reason this is starting at 0 is because arrays are 0 based. So if there's going to be 10 annotations in this vAnns array that gets returned, then we'll start at 0 and we'll go to the upper bound, which will be 9. And for each one of those, we'll set our annotation object variable equal to that element. And then we can use one of the members within iAnnotation. So in this case, if I use select3 just as an example here, let me put in some arguments. We'll say true and nothing. What's going to happen if I run this right now, it should get all the annotations in the selected drawing view, and then it's going to loop through all those annotations and select each one. So with this bit of code, we can kind of prove that we're where we need to be at this point in the macro. So let me run this, and I get object variable or with block variable not set. Why is that? Well, let's click debug. It takes me to this SWView.getAnnotation line, And it may not be obvious right here what's going on, but if we move our cursor back up to SWView on the previous line, you see that it says that this was equal to nothing. Why is it equal to nothing? Aren't we getting the selected view? Well, if we go back to SolidWorks, we see that we don't have the drawing view actually selected right now, and that was the problem. It was trying to get the selected object and we didn't have anything selected. So let's click that. And what we can do then is restart this. I'll just hit stop and then I'll click run again, and notice we didn't get an error this time. And if I go back here, you see that all of the annotations are selected as we intended. So it looks like everything is working okay thus far, and I'll go ahead and remove that. Before we get the entities that the note is attached to, however, I just want to point out something that you may have already noticed. The API forms a type of hierarchy, and at the top of that hierarchy are the higher level objects. So for example, this variable that we're using to represent the entire SolidWorks application, that was the first object we got. Then after that we got the second highest object, which is SWModel, and that makes sense. Before we can do anything with a model, we need the application itself. And then before we can get a selected object view, we need to get the selection manager, which is part of the model, and so on and so forth. And then once we have the view object, then we can get the annotations within that view. And then before we want to do anything with the annotation object, we need to get that annotation object, and so on. So you can see how we're working from higher to lower objects, and that's a very key point of understanding the SolidWorks API. So keep an eye out for that as we continue to work from higher to lower objects to reach our objective. So now let's grab these comments, and I'm actually just going to put them in here since all of this code is going to be run while we're in this loop. And so the next thing we're going to do is get the entities the note is attached to. It's important to note that we don't want to get the entities for every single annotation, because think about it. A dimension is a type of annotation, but are we interested in traversing dimensions? No. So if for some reason this drawing view had been dimensioned and we tried to get entities associated with the dimension, then we would end up going down a rabbit trail, because this really isn't of interest to us and we might end up deleting something that we didn't mean to delete. So what we need to do first is actually create a conditional in our code that makes sure that we're only examining annotations of type note, because a balloon is considered a note within the SolidWorks API. So I'm going to say if SWAN.getType equals SWNote, and again, if you're not exactly sure where I would have got this code, well, go in the API help, look up the getType API call that belongs to the iAnnotation interface, and you'll see the list of options that you can test for. In this case, we're testing to make sure the current annotation is a note. So if it is a note, then, and then down here at the end, I'll put in an end-if statement. Then we want to get the attached entities. So what I'm going to do now is come back up here and create a new variable called dim attached entities as variant, and we'll say v attached entities equals SWAN get attached entities 3, and there's no arguments with that. So this is going to return an array of all the attached entities. And if you're not familiar with the specific definition of entity, an entity technically is something like a face, an edge, or a vertex. So this is going to return one of those three objects. And in the case of a balloon, if we come back here and think about it, these balloons should each only be attached to one entity. So if I zoom in, it should either be attached to just one edge or one face, and so on. So that means we don't need to create a loop. We can just assume that there's only going to be one element in this array, and I'll show you how to retrieve that. We'll just say set swint equals v attached entities 0. So previously in this other loop up here, we had a for loop, and this would have been I, and we would have looped through everything in here, but we don't need to. We're just going to assume only one entity. And then the other thing, you noticed I typed SWInt here, but I haven't declared that yet, so let me go up here and do that. This is going to be as entity. And entity is kind of like a parent interface for faces, edges, and vertices. It can be used to represent any of those. And like we did earlier, it would be appropriate at this point to create some sort of test to make sure that we're headed in the right direction. So again, I'll use a select method, which is available with iEntity, and we'll say select for. And I'll put in some arguments there, and now if I run this, it should select all of the entities that the balloons are attached to. So let's not make the same mistake we did before, and let's actually come in here and select this, and now if I click run, we get type mismatch. So why are we getting type mismatch? Well, if I move my cursor over V attached to entities, you see that it is empty. So since it's empty, you cannot set empty equal to a variable that can only hold iEntity objects. So that's why we're getting the type mismatch. But the question is, why is this empty? And then also, what can we do to prevent this problem? Regarding why it is empty, let's go back to SolidWorks and go up to help. Make sure that Use SolidWorks Web Help is turned off, and then go to API Help, and that will bring up the local API help. And then once you're in the index tab, you can type in get attached entities and double click on that. And this contains a lot of valuable information about this method. And again, if you want to research a particular interface or API call, you would use the API help. For example, right here it shows what types of objects can be returned by this method. And if you were to read the remarks, the last thing you would read is this. If this annotation is not associated with any geometry, for example a note without a leader line, then SolidWorks returns an empty array. Now if we go back to our model, we see that each one of our notes is indeed attached to something. So why are we running into this issue? Well, go back to the VB editor, and if we move our mouse cursor up to U-bound VANs, notice we get a value of 5. Now keep in mind that 5 is not the total count because VAN starts at 0. So in fact, there must be 6 elements in VANs, and one of them, in this case since I is still on 0, it must be the first one. The first one, whatever it is, it seems to be invisible and it does not seem to be attached to anything. I'm not exactly sure what that annotation is. Since we know that this is probably going to be a recurring problem, let's go ahead and just solve the problem by doing this. Right after we get the array, let's say if is empty, and is empty is a built-in Visual Basic function, v attached entities equals false. So basically, if that array is not empty, then we're going to run the rest of this code and we should be okay. So we can drag this above this, and that way it'll start executing at that line again. And if we run it, we see that we get no errors. And my line involving the selection got deleted out on accident on my end, so let's go ahead and re-add that. I'll do true, nothing. So run this again while this is selected, and we should select all of the attached entities. So run that, we did not get an error. There are all of our edges now selected. So now that we've verified that we are where we need to be with this macro, let's go ahead and remove that line. And next up is get the underlying component for that entity. So first we got the annotations, we determined if they were notes, then we got the entities attached to those notes, and now we need to get the component from those entities, and to do that we can use an API call that's called iEntity get component. So before we can use this, we need to declare a component2 object variable, and we're going to say set swcomp equals swint get component. So just like that, we're going to get the interface for that underlying component, and now we need to determine if the component is from the toolbox. So you might be thinking, well, maybe there is an API call called something like isFastener that returns true or false. Well, we could find out real quick in the API help if we type in isFastener, and you see that such a property exists for this other interface called iInterference, but unfortunately it does not exist for iComponent2. So you might say, well, no problem, maybe there's something else in there. If we just go into the iComponent2 members list, maybe it's called something else. So let's search for toolbox. Nope, no results. Search for fastener, still no results. So long story short, there is no API call that lets you quickly determine whether a component is a toolbox part or not. Instead, what we can do is take advantage of the fact that we probably know where the toolbox is stored on our hard drive or on our network. And so in my case, I know that it is in a folder called C drive SolidWorks data 3. So what I can do is I can use this API call get path name that says gets the full path for this component, and that will return a path containing C drive SolidWorks data 3. And I can just look in that string and say, well, if C SolidWorks data 3 exists, then we'll assume that that component resides within the toolbox, and we'll assume that it is a toolbox fastener. So let's go back here and do that. We'll start off simple. First, let's just say debug print swcomp get path name, just to make sure that we're able to return the paths we want with no problem. So let me make sure this is selected, come back here, and if I run this now, here's our 5 components, and you can see that here's one with C drive SolidWorks data 3, and here's another one. So there's several ways we could handle this. We could use the inString function and see if this string exists within the string returned here. But in this case, I'm just going to use the left function, and that's going to let me grab a certain number of characters on the left side of the string. And in this case, 18 will be good enough, and that way, if I'm dealing with an earlier version of Toolbox, because I do have several of these on my hard drive, then it will still work successfully with those. So what I'll do is say if left, and there's the string, and then we'll say 18 equals C drive SolidWorks data, then we'll indent that in. Then we're going to select that annotation and delete it. And the reason we're selecting it is because if we go into the API help and take a look at edit delete, which is the method we're going to be using to delete that balloon, notice it says deletes the selected items. So the balloon has to be selected first. So we're going to say SWAN select. We'll say false here, that way we don't append all the selections onto one another, and then say nothing, and then we'll say SWModel edit delete, and put this back up here. Okay, so let's try this out. First of all, make sure that this is selected. Then come back in here and click run. Come back here, and sure enough, the balloons associated with the toolbox fasteners are deleted. So at this point, if you wanted to kind of take this macro to the next level, you might also implement some error handling up at the top that makes sure that, for example, a drawing is open before you run the macro, or make sure that a drawing view is selected before running the rest of the code. Another thing you might do is test to make sure that VANS is not empty, because if we ran this on a drawing view. But that's all I'm going to show you for right now. I hope you enjoyed this. Please give me your feedback, and of course, Please join our mailing list so you can keep up with all the new content that we're going to be adding at cadsharp.com. So thanks for watching.